What if everything you thought you knew about the planets in our solar system was completely wrong? Forget the colorful textbook images and childhood fantasies, because the reality of our cosmic neighborhood is far stranger, more terrifying, and infinitely more fascinating than you could ever imagine. Today, we're going on a journey through our solar system to uncover the shocking truth about each planet, and trust me, you'll never look at space the same way again. Let's start with Mercury, the closest planet to our sun. You might think Mercury is just a small, boring, scorched rock, but the reality is absolutely mind-blowing. During the day, Mercury's surface temperature reaches a staggering 430 degrees Celsius, hot enough to melt lead. But here's where it gets weird. At night, temperatures plummet to minus 180 degrees Celsius. That's a temperature swing of over 600 degrees, the most extreme in our entire solar system. Imagine standing on Mercury's surface as the sun rises. It would appear almost 3 times larger than it does from Earth, and the sky would be pitch black because Mercury has virtually no atmosphere. But the strangest thing about Mercury? It's shrinking. The entire planet is contracting as its iron core cools, creating massive cliff faces called scarps that stretch for hundreds of kilometers. Now let's venture to Venus, often called Earth's twin, but that nickname couldn't be more misleading. Venus is basically hell incarnate. The surface temperature is a constant 465 degrees Celsius, even hotter than Mercury, despite being nearly twice as far from the sun. Why? Venus has a runaway greenhouse effect with an atmosphere so thick that the atmospheric pressure at the surface is 92 times that of Earth. Standing on Venus would feel like being 900 meters underwater. The atmosphere is almost entirely carbon dioxide with clouds of sulfuric acid that rain down, but the rain never reaches the surface because it evaporates in the intense heat. Here's something that will blow your mind. A day on Venus is longer than its year. Venus takes 243 Earth days to rotate once, but only 225 Earth days to orbit the Sun. And it rotates backwards compared to most planets. If you could survive on Venus's surface, you'd see the Sun rise in the west and set in the east. The Soviet Venera probes that landed on Venus in the 1970s and 1980s survived less than 2 hours before being crushed and melted by the hellish conditions. Let's talk about Mars, the red planet that everyone dreams of colonizing. The reality of Mars is harsh and unforgiving. First, that romantic red color? It's rust. The entire planet is covered in iron oxide dust that gets whipped up in planet-wide dust storms that can last for months. Mars has the largest dust storms in the solar system, sometimes engulfing the entire planet. The atmosphere is incredibly thin, less than 1% of Earth's atmospheric pressure, which means liquid water can't exist on the surface. It either freezes instantly or evaporates. The temperature averages around minus 60 degrees Celsius, but can drop to minus 125 degrees at the poles in winter. Mars has virtually no magnetic field, which means the surface is constantly bombarded by deadly radiation from the sun. Any future Mars colonists would need to live underground to survive. But Mars does have some incredible features. Olympus Mons is the largest volcano in the solar system, standing 21 kilometers tall, nearly 3 times the height of Mount Everest. Valles Marineris is a canyon system that stretches over 4,000 kilometers long and up to 7 kilometers deep, making the Grand Canyon look like a scratch on the surface. Now we reach the gas giants, and Jupiter is absolutely terrifying in its scale and power. Jupiter is so massive that it contains more than twice the mass of all other planets combined. You could fit 1,300 Earths inside Jupiter. But here's the reality check. Jupiter has no solid surface. If you tried to land a spacecraft on Jupiter, you'd just keep falling through layers of increasingly dense hydrogen and helium gas until the pressure would crush your spacecraft like a tin can. The atmospheric pressure near Jupiter's core is estimated to be 2 million times that of Earth. Jupiter's Great Red Spot, that famous storm you see in pictures, is a hurricane that's been raging for at least 400 years. It's so large that 3 Earths could fit inside it. Wind speeds reach over 400 kilometers per hour at the edges. But the Great Red Spot is actually shrinking. Observations show it's getting smaller, and scientists aren't entirely sure why. Jupiter also acts as our solar system's vacuum cleaner, its massive gravity pulling in comets and asteroids that might otherwise hit Earth. In 1994, astronomers watched as comet Shoemaker-Levy 9 broke apart and slammed into Jupiter in a series of impacts that left dark scars visible from Earth. Saturn, the ringed beauty of our solar system, is equally fascinating and bizarre. Those magnificent rings? They're not solid. They're made of billions of chunks of ice and rock, some as small as grains of sand, others as large as mountains, all orbiting Saturn in a disk that's incredibly thin. The rings extend up to 282,000 kilometers from Saturn, but are only about 10 meters thick in most places. If you could shrink Saturn's rings down to the size of a football field, they'd be thinner than a piece of paper. Saturn itself is the least dense planet in our solar system. It's so light that if you could find an ocean big enough, Saturn would float. Like Jupiter, Saturn has no solid surface, just layers of gas getting denser and hotter as you descend. Saturn's moon Titan is stranger than the planet itself. It's the only moon in our solar system with a substantial atmosphere, and it has lakes and rivers, but they're not water. They're liquid methane and ethane. The temperature on Titan is minus 179 degrees Celsius, cold enough that water ice is as hard as rock. Recent discoveries suggest Titan might have a subsurface ocean of liquid water beneath its icy crust, making it a potential candidate for extraterrestrial life. Uranus is the forgotten ice giant, and it's absolutely bizarre. First off, Uranus is tipped on its side. Its axis of rotation is tilted 98 degrees, which means it essentially rolls around the sun like a ball. Scientists think a massive collision early in the solar system's history knocked Uranus onto its side. This creates the strangest seasons imaginable. Each pole gets around 42 years of continuous sunlight, followed by 42 years of total darkness. Uranus is classified as an ice giant, but that doesn't mean it's covered in ice you can skate on. The ices on Uranus are actually super hot, dense fluids of water, methane, and ammonia existing under enormous pressure. The atmosphere is primarily hydrogen and helium, but it's the methane that gives Uranus its distinctive blue-green color. Uranus is incredibly cold, with atmospheric temperatures dropping to minus 224 degrees Celsius, making it the coldest planet in our solar system, even though Neptune is farther from the sun. The reason is still a mystery, but scientists think Uranus might have an unusual internal heat source, or lack thereof. Neptune, the final planet in our solar system, is a world of supersonic winds and extreme conditions. Neptune has the fastest winds in the solar system, with speeds reaching up to 2,100 kilometers per hour. That's faster than the speed of sound. These winds create massive storm systems, including the Great Dark Spot discovered by Voyager 2 in 1989, though that particular storm has since disappeared. Like Uranus, Neptune is an ice giant with a similar composition, but Neptune is significantly more active. It radiates more than twice as much heat as it receives from the sun, and scientists still aren't entirely sure why. Neptune's deep blue color comes from methane in its atmosphere, but there's likely another unknown component that makes it a deeper blue than Uranus. Neptune's largest moon, Triton, is one of the strangest objects in our solar system. It orbits Neptune backwards, suggesting it was captured by Neptune's gravity, rather than forming alongside the planet. Triton has active geysers that shoot nitrogen gas and ice particles 8 kilometers into space. The surface temperature is minus 235 degrees Celsius, making it one of the coldest known objects in our solar system. Let's not forget about the dwarf planets and the outer solar system. Pluto, famously demoted from planet status in 2006, is far more complex than anyone imagined. When NASA's New Horizons spacecraft flew by Pluto in 2015, it revealed a world with towering water ice mountains, vast plains of frozen nitrogen, and a multilayered atmosphere. Pluto has a heart-shaped region called Tombaugh Regio that's covered in nitrogen ice. Scientists discovered that this ice is constantly renewing itself through a process similar to convection, creating a surface that's geologically active despite being so far from the sun. The temperature on Pluto averages minus 223 degrees Celsius, and it's so far from the sun that sunlight takes over 5 hours to reach it. The reality of our solar system is that it's a collection of extreme environments, each more hostile to human life than the last. There's nowhere else in our solar system where humans could survive without extensive life support systems. Earth is the only planet with liquid water on its surface, a breathable atmosphere, and a magnetic field that protects us from deadly radiation. Every other planet would kill you in seconds or minutes without protection. Mercury would roast you on one side and freeze you on the other. Venus would crush you, cook you, and dissolve you all at once. Mars would freeze you and irradiate you while suffocating you in its thin carbon dioxide atmosphere. The gas and ice giants would crush you with pressure and freeze you simultaneously, assuming you could even find a place to stand. But here's the incredible part. Despite these harsh realities, each planet tells us something profound about how planets form, how atmospheres evolve, and how rare and precious Earth truly is. Jupiter's massive gravity has protected Earth from countless asteroid impacts. Saturn's rings teach us about planetary formation and orbital mechanics. Venus shows us what can happen when a greenhouse effect runs wild, a cautionary tale for our own planet. Mars holds clues about whether life ever existed beyond Earth. The ice giants challenge our understanding of planetary interiors and magnetic fields. The exploration of our solar system has revealed that reality is far more interesting than fiction. Every mission, every probe, every telescope observation reveals new mysteries and answers old questions while raising new ones. We've learned that planets can have diamond rain, subsurface oceans, active geology billions of years after formation, and weather patterns that dwarf anything we experience on Earth. The reality of other planets in our solar system isn't disappointing, it's awe-inspiring. These worlds are laboratories for understanding planetary science, testbeds for future exploration technologies, and reminders of how special our own planet is. As we continue to explore our solar system with increasingly sophisticated robots and telescopes, we keep discovering that what we thought we knew was just the beginning. Every planet has secrets waiting to be uncovered, mysteries that will take generations to solve. The reality of our solar system is dynamic, violent, beautiful, and utterly fascinating. It's a cosmic neighborhood where every world is unique, every discovery challenges our assumptions, and every mission reminds us that we're just beginning to understand the incredible diversity of planetary environments that exist right here in our own backyard. So the next time you look up at the night sky and see Venus shining bright or Mars glowing red, remember that these aren't just points of light. They're entire worlds with their own stories, their own extreme conditions, and their own roles in the grand cosmic dance of our solar system.